first one. This one, that is not either.
The way I've drawn it, it does not appear to be either.
Yeah, that one is not either. But that one is local maximum.
Okay. I want you to look at the way it's drawn in the book, rather than the way that I have it here,
Mm-hmm.
and determine if your answers would be the same. I think the first one is really the only one that mine is.
Because it can be like local minimum would be like either.
Okay, so I think the confusion is over the word local. There are two kinds of minimums and maximums
Yeah.
you look at for a function. There's the local minimums and maximums, and then there's the absolute minimum and maximum. Absolute are much easier to get a grasp on. That is the point that is the highest or the lowest for the entire function. However, they're harder to pinpoint on a graph because you have to remember that your graph is finite, and there may be some other point sitting outside of your space.
Yeah.
And it actually takes some calculus knowledge to determine whether something is an absolute maximum or minimum, because you have to be able to determine, all right, I think this one's the smallest, and I can show that it's always increasing over here and always decreasing over here, so it is in fact the maximum. Local ones, in order to be a local maximum or minimum, to be a local maximum, you just have to be the biggest thing near you. In other words, I have to say something's a local minimum, maximum, let's start with that case, because the minimum case follows pretty easily from it. I have to be able to draw a little neighborhood, which there is a mathematical definition for neighborhood, but for our purposes, it's just going to be kind of a little thing here. Where inside of that neighborhood, and the neighborhood can actually get really, really tiny, but inside of that neighborhood, I'm the biggest thing around. That makes me a local maximum. Locally, I'm the biggest thing around. So you may be the mayor of your city, but you're not the governor of your state, right? So you're the biggest guy around, but not.
So then 2 and 2 would be local minimum.
It would indeed. So this is now the smallest thing around, so that is a local minimum.
And 1, -4 looks, it's close, but it's not always
The
there.
way I've drawn it, it's not, because there's this point right next to it.
But even on the graph, well,
it's hard to tell.
On the graph, it's the middle. It's
that one's slightly
actually,
bigger.
I think on the graph it
still
is
studying that, no?
it's barely the local maximum.
Yeah. Right. The way I've drawn it, this point might be slightly bigger. So what's happening is at this point, if you continue along the function keeps increasing.
It's not a local maximum.
And so it's not a local maximum. So what has to happen in order to be a local maximum or local minimum?
Has to be on the tip of the bell
The
curve.
function has to change direction here. So it has to turn around, because if it doesn't turn around, if you continue in the direction you've been going, then you're either going to have something right next to it that's slightly bigger or slightly smaller, ruling out maximum and minimum. So notice that at the 3 points here, our function is coming up, we hit that point, we turn back around. So it's the biggest thing. Down here, we hit this bottom point, come to our point, and we change direction again. So that makes it the local maximum. It's going to be a place where you change direction. Go ahead and ask your question.
So -1, 4 is considered a local maximum?
In the way it's drawn in the book, that is a local maximum.
Okay.
Yeah. Alright, so let's do another